Hi, my name is Peter So. I'm a Robotic Manipulation Researcher here at the Technical University of Munich at the Munich Institute for Robotics and Machine Intelligence. Robotics has its roots in automotive manufacturing, and we've seen from the very beginning with Unimate creating repetitive motion on a manufacturing line is very valuable. And so as we've seen robots become more and more advanced, this means that they become more adept and in tune with their environment. And so what's special about our robot platform with Franco Robotics is that we have a 7 degree of freedom robot that has force and torque control through all the joints and allows us to interact not only with the environment, but essentially work in proximity to people without a cage. So this box essentially is a representation of the different tasks that our industry partners have identified as important open questions for robotics research. And this box has essentially 5 different tasks. First is just basically find it on a table, press a button to confirm. Then we have an interactive element where we have a slider which moves along its axis to find different waypoints that are set on the screen. Then it takes actually this probe. This is a probe that you would find in an electronics lab. It's a multimeter probe. And then it moves it actually from a starting port into a test port, for example, so this red one. And so here it actually does a spiral search to try to feel its way into that hole. And then you'll see a little cute little bump here just to push it in and make sure it's all the way in. And then the idea here is that we would try to replicate an industrial inspection with a terminal block that's hidden inside the box. And so one of the tasks is then to open a door and then take the multimeter probe and actually insert it into the electrical circuit inside the box. And so that's what it's going to do right now. And what's really great about our setup is that this robot is actually interactive. So actually interact with the robot here to guide it into position if it can't find its way.
The goal with this box was actually to define a benchmark. So it's the same problem where people have to compete or to work on solutions with their own robots and with their own methods in order to solve the same problem. And I think this provides a very objective evaluation or assessment of the methods developed in different labs. This is a very important step for benchmarking.
So here at the TUM and the MERMI, we want to focus on robot research and manipulation. This specifically goes from the next evolution from robots working in a manufacturing line with high speed and high rigidity to new age robots which are working in the environment with their environment, which have the ability to create a compliant motion. And this allows us to compare how a human would interact with a robot directly without a cage. And this is something that is unique and is what we're going to see in the next level of robots as we see them coming into shared spaces with humans. When we actually begin to interact, if you imagine a robot handing a cube to your 5-year-old, for example, how does it know when to hand off? When does it know to let go? This is the skill and the interaction we're looking to develop with our platform here at the robot development inside the euROBIN project.